Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have discussed about the various kinds of forces present in nature as well as about the contact and non-contact forces. So today, we are going to mainly discuss about the three laws of motion which are given by Sir Isaac Newton. So this is also regarded as the Newton's laws of motion. Okay, so there are three laws. So without wasting much time, I'll be quickly moving on to the video. Okay. So I hope everybody of you are studying properly and following our videos regularly. If you have any comment or any problem, you can mention in the comment section. Any query, we will be happy to solve your queries. Okay. So with that, we start with today's topic, Newton's first law of motion. So Newton's first law of motion. So before beginning Newton's first law of motion, I will be briefly discussing about the rest and motion that we have discussed earlier also. So I hope you have remembered what actually mean by rest and what actually mean by motion. Remember, rest is that condition when the position of an object does not change with respect to its immediate surroundings in a certain interval of time. Then that object is said to be at rest. And motion, when the object changes its position with respect to its immediate surroundings in a certain interval of time, then that time it is said to be in motion. So you must have remembered this, we have discussed in the previous chapter. Basically, what does Newton's first law tells us about? So let us first come to Newton's first law. So Newton's first law. So what is the first law all about? Okay. So the Newton's first law is also known as the law of inertia. So it is also known by the name of law of inertia. So also known as law of inertia. Now you must be wondering, what is this inertia? Okay. So we will be discussing about this inertia a little later. Just we first describe the first law, then we will be talking about the inertia. Now, what does the first law say? It is very common. You sometimes have observed this thing happening, or actually it is happening every time around you, but you may have noticed it sometime that when an object is in rest, suppose a book lying on the table tends to remain at rest until you move that book by yourself, isn't it? Or say the glass kept on the table remains in its position of rest until you cause the glass to move, or you pick up the glass and keep it anywhere else. Thus, actually, we see that any object which is in the rest condition, static condition, remains in that position as long as no external cause causes it to move from its position. Likewise, you must have also seen that when you kick a football, you see the ball keeps on rolling on the ground, isn't it? The ball keeps on rolling on the ground, and it eventually keeps on rolling until and unless some person stops it. Or you may also say that yes sir, it actually stops after moving a certain time, even if any other person does not stop it. Why does that happen? That happens because of the force of friction. We have already discussed about the force of friction. So you know what is force of friction? It opposes motion. So actually, if there was no friction, it would have been observed that the ball would have kept on moving and moving and moving. So it would have not stopped. So basically, what we are trying to say, what Newton's first law stated that. So it stated that an object in rest continues to be in rest and an object in motion continues to be in motion until and unless acted upon by an external force. Okay. So basically what happens, we can say that the object will remain at rest until an external force is applied on it, or an object which is moving will keep on moving until an external force acts on it. Thus you can say that an object continues to be in its state, it may be the state of rest or state of motion, until and unless an external force is applied on it. So this is basically the Newton's first law. Very simple but very important. Okay, so what conclusions or what thing can we describe using this law? There are two things that we can get from this first law. We have already said that the first law is also called the law of inertia. So actually from the first law we get the actual meaning of inertia, as well as we get to know what a force is. Okay, so if we just see the qualitative description of the Newton's first law, so if we just analyze the qualitative meaning of the Newton's first law, I hope you have written it down. It is in the book, but still you can at least write it down once, so that it becomes easier for you to remember, because more you practice, more easier it is becoming for you to remember. Okay, so this Newton's first law, so there are two qualitative meaning. So if I just arrive at the qualitative meaning, so basically there are two meanings that you can actually bring out from this law. One is the inertia, okay, and second is the force. We can actually describe these two terms using the first law. See, what is meant by inertia? It is said that in the Newton's law, that an object in motion continues to be in motion, or an object in rest continues to be in rest. That is, it continues to be in the state it is present. Okay, so why does this happen? This is happening due to a property of material, due to property of any substance, which is known as inertia. So basically inertia is that property which causes an object to retain its state of rest or state of motion. So just think about yourself. When you are sitting in a room, you feel like sitting in a room for a long time, until and unless some thing gets reminded in your mind and you think that, oh, I need to do that work. Only then what you do, you get up and start doing that work. But unless that, so that is actually an external cause is causing, external cause is impacting you, then only you change your position or you change your state of rest. Else we tend to stay at the position of rest. Okay, so basically this is not only the property of any living matter, this is property of all kinds of matter, living or non-living. Any object which is at rest tries to be in rest, and which is at motion tries to be in motion, and this happens due to the property of a substance called the inertia. Inertia is that property of substance which is basically responsible for this kind of behavior of any matter. Okay, so this is inertia. And what explanation do you get about force? So in the last line it has been said that unless and until acted upon by an external force. So basically you can say, what is force? It is the external cause. It is a cause which is responsible for bringing a change in the state of the object, isn't it? So basically force is an external cause that is bringing the change in the state of the object. So these are the two definitions that you can come that you can define from the Newton's first law. Okay. Now we will be discussing how the inertia of an object and mass of an object are related to each other. So can you think of how inertia and mass of an object is related? Inertia and mass. Inertia and mass. See, it will be easier for you to understand if we just take some practical examples. Say there is a box on the ground which is, say, filled up with cotton. Okay, now it is at rest, it is kept on the floor at rest. Now it is easier for us to just move that box, because we can actually move that box by applying very small amount of force. We do not need to apply a large amount of force. Whereas if you consider another box which is having, say, any iron object in it, okay, so it's much heavier than the previous box, it is quite difficult to move that box, and we need to apply basically much greater force than the previous case in order to move it. So what happens? More the mass, actually what happens, more the mass, okay, more the mass, okay, so more is the force required to change its state, required to change its state. More the mass, more is the force required to change the state. Is it clear? So more the force, more the mass, more is the force required. That is, we can say definitely why more force is required, because inertia is actually greater for that kind of body which has more mass, and the reverse is also true. Less is the mass, less is the force needed to bring about a change in the state. Just imagine if a say a four-wheeler, okay, a four-wheeler, a car is running at a certain speed, say 20 km/h, and a cycle is running at a speed of 20 km/h. Just try to imagine in which case will you require more force to stop the car or the bicycle. Definitely it's the car which requires a greater force to stop it, whereas you can easily stop the bicycle by applying quite a less force than that in the case of car. So from these examples you can easily understand that more is the mass, more is the inertia, less is the mass, less is the inertia. So basically mass and inertia of an object are very much deeply related. So we can say that mass is a measure of the inertia. So we can say that mass is a measure of inertia. Okay, mass is a measure of inertia. We do not get any direct expression for inertia, but the mass is an indirect estimate of the inertia. Mass is a measure of the inertia. Okay, fine. So this is actually mass and inertia relation. Okay. So with that we will come to an end to our lecture. In the next lecture we will be discussing about the kinds of inertia, and we will be taking up some examples, some illustrations to see how this Newton's first law is being applicable to our daily life applications or daily life situations. Okay, with that we say thank you, tata, goodbye, do study well.